All right, so point slope form. Point slope form is just another method of being able to write a linear equation. So we've seen two other methods for writing linear equations. We saw slope-intercept form. Slope-intercept form being that y equals mx plus b. We've also saw our standard form yesterday, that ax plus by is equal to c. Now here's a third format that we're learning on how to write linear functions. And that is point slope form, where you are given slope. Slope is still the value of m. And then you are also given a point that is going to reside on the line. That might not necessarily be your intercept. Excuse me, sorry. So what we do is we write it down as an equation where y and x stay variables, and then y1 and x1 represent the coordinates of your point that falls on your graph, and m is going to represent your slope. So let me go ahead and highlight that for you. So y1, again, is going to represent the point, the coordinate y1 on your point. Your x1 is going to represent the x coordinate of your point. And then, as always, our slope is going to be represented by the value m, which represents the slope. Okay? So you need to make sure that you are mindful. It's very, very important to be mindful of those negative coordinates because it's y minus. So if your coordinate happens to be a negative, then it's going to be minus a negative. If your coordinate happens to be positive, it's just going to be minus and then whatever your positive value is. You need to be very careful about those negatives because a lot of times people like to drop their negatives because they automatically see the subtraction. They think that that's already the negative there, and that's not. Okay, so this is subtracting whatever your y1 value is or whatever your x1 value is. Okay, so be very careful about those negative signs. So let me go ahead and show you an example. If I give you a point, so on my line that I've graphed, I have the point 2, 6. 2 being my x value, 6 being my y value for my coordinate, and that I know that my slope is going to be 3/2. So I want to go ahead and translate this into an equation. So the first thing that I would do is place it into that format, y minus y1 equals m times the quantity of x minus x1. So I want to identify what each of those variables is going to be represented as. So I know the value of m in my equation. I'm going to go ahead and replace it with the 3/2. I know wherever I have the values x1 in my equation, I'm going to replace it with the value 2. What's wrong? Tissue. Is there not a box of tissues? Here, let me pause and I'll get you one. All right, so x1 is going to equal the value 2 because that's our x1 coordinate. Right, x1 is going to be located right here. And then our y2 coordinate is going to be represented by the 6. Or sorry, not y2. y1 coordinate is represented by the value 6. All right. So like I said before, our equation is going to be y minus y1, and it's set equal to m times the quantity of x minus your x1. So then you're just going to substitute all the values into our equation. Something I like to tell my students to do when they're first starting is just to go ahead and write y minus, write your equal sign, write your parentheses and put x minus, and then your parentheses again. Just set up everything that you know is going to be constant, those that are not going to change. Okay, the only thing that is going to change is whatever my y1 is. The reason I tell everyone to do that is because if these happen to be a negative, then you've already got the minus sign set up. You know that you're just going to go ahead and fill in a negative here or a positive, whatever it's going to be. Okay, y1 in this case happens to be a positive 6, so I'm just going to replace it with a 6. The m, when I fill this in, is going to be the fraction 3/2. right? We know slope to be fractions. If it's a whole number, it's still a fraction over 1. And then our x1, we're going to replace that with the value 2. So there's our point slope form. Y minus 6 is equal to 3 over 2 times the quantity of x minus 2. So if they wanted you to put it in point slope form, you'd be done. If they wanted you to then take it and write it into slope intercept form, that's when you would have to start solving and converting so that you could get y by itself, which is what we're going to do here. Okay, so we're going to take the equation that we just wrote for point slope form. Y minus 6 is equal to 3 over 2 times the quantity of x minus 2. And the first thing that I always do is what? Remember, if you don't remember, look back at the board, the solving equations board. What does it say step 1 is going to be? To distribute. You need to make sure you distribute first. We always simplify before we solve. You simplify first, simplify everything you can, which means distributing and combining like terms. Then you start solving, which means you start moving things to opposite sides. That's when you do opposite operations. So the fact that we have a value outside of a quantity that's in parentheses, then you want to make sure you do that distribution first. So we're going to take 3 over 2, we're going to multiply it with the x, and we're also going to multiply it with the minus 2, the negative 2. Keep that in mind, that minus 2 now acts like a negative sign when you're doing an operation. So we need to make sure we distribute first. So we're doing 3 over 2 times x, and we're doing 3 over 2 times negative 2. 3 over 2 times x is just 3 over 2x. 3 over 2 times negative 2 just comes out to a negative 3. Okay, so I've done my distribution. I'm going to bring the rest of my equation down. That y minus 6 is going to come down on the left side. Now I've simplified everything. I don't have any more distributive property. I don't have any like terms that can be combined on the left side. I don't have like terms that can be combined on the right side. So now I can move over into the solving process where I start doing those inverse operations. So the only inverse operation I need to do is to get that y isolated. So what's the inverse operation I need to do in order to get y isolated? Add 6. I'm going to add 6. Now, addition and subtraction have to happen to like terms. So when I put add 6 on the other side, am I going to add it with the 3/2 x, or am I going to add it with that minus 3? The minus 3, because those are the like terms, aren't they? So I'm going to put plus 6 right underneath where I see my minus 3. I can now go ahead and box these off and cancel them. And what I'm left with is y equals 3 over 2x, and then what is negative 3 plus 6? Positive 3. So I would put plus 3. And there's my slope-intercept form. Okay, so you have to understand how to write in point-slope form and how to convert point-slope form into slope-intercept form. Okay, I want you guys to go ahead and try example 2 and example 3 on your own. Just example 2 and 3. Okay, for problem 2, my slope happens to be a 4. You could just put 4. If you put 4 over 1, that's fine, but 4 is perfectly fine as well. My x1 coordinate is going to be a negative 2, so be mindful of those negatives. My y1 coordinate is just going to be a positive 3. So when I'm substituting this in, we're going to do y minus, and remember it's y minus the y1 coordinate, so we're doing y minus 3 is equal to my slope. My slope is 4 times a quantity of x minus, and it's going to be subtracting my x coordinate, which is a -2. So we should have x minus -2. Now, here's the thing. We're not big fans of double negatives. So whenever you see a double negative here, we like to go ahead and rewrite those. So remember, a double negative equals a what? A positive. Double negatives equal a positive. So when I rewrite this, I'm actually going to write it as y minus 3 is equal to 4 times the quantity of x plus 2. Okay, I'm going to take that double negative and I'm going to convert it to a plus 2. Everybody clear on that? Okay, so this is what our slope or point slope form should look like. We're now going to take this equation and we're going to start converting it into our slope intercept form. So again, what do we always do first? Say it louder, Train. Distribute. We need to make sure we distribute. We're going to do 4 times the x and we're going to do 4 times the positive 2. We're using our distributive property rule first. Remember, it's always multiplication, so that becomes 4x plus 8. Okay, 4 times x is 4x. 4 times 2 is positive 8. Okay, so now we've got y minus 3 is equal to 4x plus 8. And now we are going to go ahead and do our inverse operation by adding 3 on the left side so that we can cancel out the 3's. And then I'm going to add 3 to what value? To the positive 8. We're going to add 3 to that positive 8. And our final answer is y equals 4x plus 11. Your final answer should be y equals 4x plus 11. Okay. Our next example, example 3. What's our slope? -1/2. What's the x1 coordinate, guys? -1. The y1 coordinate, positive 2. Okay, so we're going to substitute these in. It should be y minus 2 equals our slope, which is -1/2, times x minus -1. Remember, I don't like those double negatives. If we've got the double negatives, we're going to change it to a positive. We don't want to keep double negatives. So we're going to convert it down to a positive. So our point slope form should be y minus 2 is equal to -1/2 x, or sorry, -1/2 times x plus 1. Okay, now we can go ahead and start converting. We're going to distribute first. We're going to take that -1/2 and multiply it by x, -1/2 and multiply it by the 1. -1/2 times the x comes out to -1/2 x. -1/2 times a positive 1 comes out to a -1/2. So we have y minus 2 is equal to -1/2 x minus 1/2. Last step, add 2 to both sides. We're going to add the 2 to the -1/2. And your final answer here should be y is equal to -1/2 x plus, you could put 1 and 1/2, or you could put 3 over 2. Or you could put 1.5. Either of those would be fine. Okay? Alright, the reason I didn't want you doing example 4 yet is because example 4 is a little bit different. Example 4 is giving you 2 points. We're giving you 2 points instead of a slope and a point. So what do you think we have to find first before we can put it into point slope form? Find the slope. Who can remember what is the formula for finding slope between 2 points? Trang, what is it? Very good. y2 minus y1 over x2 minus x1. Slope can be found by subtracting your y's over the subtraction of your x's. And it's very important that you put it in the order that you match it up. If you put y2 first, you have to put the x2 first. You can't just interchange them, because if you swap out points just because you're like, oh, well, I really don't want to do 3 minus 7, so I'm just going to do 7 minus 3 even though I'm supposed to do 3 minus 7, it's going to give you the wrong sign. And the wrong sign changes everything. Okay, so be very mindful of that. So in this situation here, we've got 2 points. We've got 8, 1, and we've got negative 2, 9. The first thing we need to do is identify what the slope is going to be. So we are going to subtract our y's. So I can either do 1 minus 9 or 9 minus 1. I'm going to go ahead and do 9 minus 1. Now, based off of the fact that I did 9 minus 1, how do I have to subtract my x's? Am I going to do 8 minus negative 2 or negative 2 minus 8? Which one? Negative 2 minus 8. Good. You have to keep it in the proper order. Since I used the 9 first for the y's, I have to use this negative 2 first because they came from the same point. Okay? Once I've subtracted, 9 minus 1 gives me a positive 8. Negative 2 minus 8 gives me a negative 10. And like always, you want to simplify them. Bring the negative out in the front. And then 8 over 10 simplifies to 4 over 5. So you get a negative 4/5 for your slope. Now, the point. Do you think it matters which point you pick? Nope. So I always strongly suggest pick a point. If it has all positives in it, pick that point. It's probably a little bit easier for you. If you pick the point that already has it as all positives, it's probably a little simpler. So I would go with the point 8, 1. That way you don't have to deal with that double negative, that minus a subtraction, or the subtraction of a negative. Okay, so I would plug it in as y minus, and again, we're going to use these as our coordinates, right? We're going to use, this is our y1, this is our x1. So we're going to do y minus 1 is equal to negative 4 over 5 times the quantity of x minus 8. Okay, so there's our point slope form. Now we're going to go ahead and do our conversion. So we're going to take that negative 4/5 and we're going to multiply it to the x and multiply it to the negative 8. So that's going to give us negative 4/5 x. And then when we do negative 4/5 times a negative 8, that comes out to 32 over 5, a positive 32 over 5. I'm going to leave them in fraction form just because it's easier. So we now have y minus 1 is equal to negative 4/5 x plus 32 over 5. The last thing I need to do is add a positive 1 to both sides. And I'll get y is equal to negative 4/5 x plus 37 over 5. And it doesn't matter, if you chose the other point, you would still get the same exact simplified y or slope-intercept form. Your point slope form would look different, but your slope-intercept form would simplify to the same thing. Go ahead and do example number 5. All right, let's go ahead and go over that. First thing I have to do is find my slope, so I have to subtract my y's over the subtraction of my x's. So I did negative 12 minus negative 8 and got negative 4, over negative 5 minus negative 2, which is a negative 3. But because I have those double negatives, it comes out to a positive 4/3. Then I just picked a point. I went ahead and went with the second point. It really doesn't matter, again, which point you go with, but I went ahead and just said that this was my y1. and this is my x1. You could have done the first point. It's going to come out to the same value. I had y minus negative 12 is equal to 4/3 times the quantity of x minus negative 5. That double negative needs to be eliminated, so it's y plus 12 is equal to 4/3 times the quantity of x plus 5. Then I distribute, and that gives me y plus 12 is equal to 4/3 x plus 20 over 3, because 4/3 times 5 becomes 20 over 3. And then I would subtract 12 from both sides. My final answer comes out to y is equal to 4/3 x minus 16/3, or 16 over 3. Okay? All right, the last thing I want to talk to you guys about are our special line equations. Those are the equations that involve slopes that are not, positive slopes or negative slopes. However, they are zero slopes or undefined slopes. Those are special equations, but they're very simple, very quick, and easy to be able to go over. So let me go ahead and turn to the page. If we are dealing with a situation that is an undefined slope, when we have undefined slopes, what we're doing is we're creating an equation that is x equals and whatever your x1 coordinate is. The reason for that is because, remember, if I graph an undefined slope just looks like a vertical line. Undefined slopes are just straight vertical lines. That means every single point on that line has the exact same x coordinate. The only coordinate that changes is the y coordinate. The x coordinate stays stationary. So it's an equation of x equals a value, not y equals. So for here, our x coordinate is a 5. So therefore, if we know it's an undefined slope, then our equation is just x equals 5. What about problem number 2? What will the equation be for number 2? X equals negative 6, because our coordinate is a negative 6. Okay, real quickly, take the next 5 seconds to do number 3 and 4, because it doesn't take that long. All right, as a class whole, number 3, what's the equation? X equals 4. What's for number 4? It's x equals negative 5. Good. Now, that was for undefined slopes. Let's talk about zero slope. If we're talking about a zero slope, remember zero slopes have a graph that looks like a horizontal line. Okay, that means that every point on the line keeps y stationary. Y will always stay the same. Okay, it's a flat horizontal line. The y value never changes. It's only the x values that change. That's what creates that zero slope. So in a situation like this, it's the same idea. Y equals and whatever your y1 coordinate was, because y will never change. So for number 1, it's going to be y equals what? Y equals 9. Number 2, what's it going to be, guys? Y equals 7. Number 3, y equals negative 3. Good. And number 4? Very good. Pretty simple. Okay, you have homework tonight. It is the quizzes. It's 20 questions, and it's on point slope form. Some of them are just going to be giving you point slope form, and you might have to identify what is the slope or what was the point that was graphed. Some of them are going to ask you to create the point slope equation. Some of them are going to ask you to convert the point slope equation. 20 questions, you get 1 opportunity. Please make sure you get it done.